In the previous lecture, we were discussing something about the sum of continue with our infinite series, but now let us try to see a few more things expanding that there is something called as telescopic series. Okay, telescopic series. This is something that we've already done. Things on sum of series. Now, just try to do this sort of question. Given that pi square upon 6, that it is convergent. Now I'm right now giving that it is convergent. That is, I'm giving 1 upon n square is pi square over 6. We want to calculate what would be summation 1 upon 2n minus what would be its. Okay, so how to do this thing? So understand that we have already given light to you right now. Okay. So summation 1 upon n square would contain what? It would contain even the even terms. I will try to use this SOPS at first. So what would be summation k equals to 1 to n 1 upon k square. So summation k equals to 1 to n 1 upon as well as the odd terms. Okay, it will contain even terms as well as odd terms. Now from here it is to 1 to n 1 upon k square, and here it is equals to summation k equals to 1 to n 1 upon 2 square common out, that's 1 upon 4. Summation k equals to of these square of these odd terms would be simply equals to what? Would be simply equals to summation k equals to 1 to n 1 upon 4 summation k equals to 1 to n 1 upon k square. If I take limit on this required here, and here also if I take n tends to infinity, this is something that we already know. This is equals to what? This is equals to pi square over 6 to n minus 1 whole square from n equals to 1 to infinity would be simply equals to pi square over 8. This was supplied to us. This was supplied to us. Had it not been supplied, can we think of convergence of 1 upon n square from the thing that we have studied till now? Understand that summation 1 upon n square is a positive term series. This is quite evident. It is a positive term. Which is the sequence of partial sum would be what? It would be equal to 1 plus 1 by 2 plus 1 by 3 dash 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 1 by n, as its SOPS does. That is, if the sequence of partial sum is convergent, then think about what is SOPS. So SOPS would be Sn is equal to 1 plus 1 by 2 square, 1 by 3 square, and 1 by n square. And if I take Sn plus 1, it is okay. Sn from Sn plus 1, I will simply get 1 upon n plus 1 whole square with such sequence. If I want to know that whether my series is convergent or not, I need to know that my SB prove to you that this Sn, that is the SOPS, is an increasing Sn. Sn must be a bounded sequence, must be bounded above. So whenever you are encountering that the sequence of partial sum associated to this positive term series is bounded above. Convergence of 1 upon n square, we need to prove that Sn associated to 1 upon n square must be bounded above k square. I'm not going into the proof of how we get the value right now, but I have already given you. But right now, telling just trying to build a thought that whether 1 upon n square be stated convergent or not. So given this positive term series comes out to be an increasing sequence, and for increasing sequence to be convergent, it must be bounded above. So let's get it with this, that is the series, that is summation 1 upon n square. Is it bounded above or not? Is it bounded above or not? Okay, this is something that we need to see. 1 upon n square, 1 upon n square will be less than equal to 1. Sorry, will be, you can see this. Okay, because if I'm talking about for n greater than equal to 2, so I can say that summation 1 upon n square, let's say k square, k equals to 1 to n, it will be less than equal to summation k equals to 1 to n, not less than equal to, sorry, strictly less than. Okay, and yesterday such steps we write inside. What I can do one thing. I can just write summation 1 upon k square will be less than, so bounded above. So this is equal to 1 upon k minus 1 minus 1 upon k. This is from 2, my mistake. Okay, so my Sn I want to prove whether it is bounded above or not. So now this will be 1 3 dash 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 1 upon n minus 1 minus 1 upon n. So in n part, so overall, I know that Sn would be less than 1 minus 1 upon my sequence of partial sum for the series 1 upon n square would be bounded. That is convergent. And if Sn is convergent, then it implies summation 1 upon n square, that I already stated the sum. But the central theme of this entire think about the convergence and divergence of the series, for which we may require help of certain. What do you think? What do you think about summation 1 upon n? So what do you think about this summation 1 upon n? Is it a convergent series or a divergent series? Clearly, this is also a positive term series. This is also positive term series. The sequence of partial sum are bounded above. Okay, so because see, if I'm stating that for this particular series would be an increasing sequence, and for convergence of increasing sequence, we need that it should be bounded above. Equal to what? Sn is equal to summation 1 upon k equals to 1 to n. We'll show that one of the subsequences S2 bounded, so clearly the sequence would be unbounded. Okay, we'll show this. Okay, now just think about S1. What would be 1 by 2? What would be S2 square? It would be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Okay. What do you think S2 की power 3 would be? It would be 1 plus 1 by 4 dash 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 1 by 8. What would be S2 की power 6? 4t. Sorry. Okay. 1 by 2 plus 1 by 3 plus 1 by 4 plus here I will write 1 by 5 and then 1 by 9 to 1 by 60 and so on and so forth. And likewise, but just first do some observation. See, one of the observation is quite clear that if greater than 1 plus 1 by 2 plus 1 by 4 plus 1 by 2. The idea behind it is that this 1 by 4, this 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 would be greater than 1 by 2 plus 1 by 4 plus 1 by 4. And these are how many terms? These are 4 terms here. 1 by 5, 1 by 6, 1 by 7, 1 by 8. So it would be greater than 4 times 1 by 8. Now this is greater than 1 by 4 plus 1 by 4. This particular bracket is greater than 4 times 1 by 8, and thus it is greater than 1.2. And this is greater than 1 upon 16 added 8 would be greater than 1 by 16. 1 by 10 would be greater than 1 by 16. 1 by 11 would be greater than 1 by 16. 1 by 12, 1 by 14 would be greater than 1 by 16. 1 by 15 would be greater than 1 by 16. 1 by 16 is fine. So overall, it says that what we are doing is we are taking those brackets in which the n term is 2 की power 2. Here the n term is 2 की power 4. And what is 9? 9 is 2 की power 3 plus perspective. So S2 की power k would contain 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. 5 is 1 upon 2 square plus 1. Okay. And what is this? What is this? This is 2. And what is this? This is simply 2 की power 2. So if I go along and write the last bracket, it will be 2 की, it is 1 upon 2 की power k minus 1 and then plus 1 added. And what are we doing? We are making the here what we did, we actually compared it with 1 upon 6. 8 is 2 की power 3 and this is 2 की power 4. What is 4? It is 2 की power 2 and 2 की power. So basically here also what I can do, here see what I'll do. S2 की power k greater than 1 upon 2, it is fine. Again greater than 1 upon 2, it is fine. 1 upon 9 to 1 upon 16, just 9 to 1 upon 16, this entire sum 1 upon 9 plus 1 upon 10 plus 1 upon 11 plus 1 upon 16. All can be written greater than 2 की power 8 times 2 की power 3 times 1 upon 6, it can be written greater than 2 की power k minus 1 upon 2 की power k. So overall if you see this is 2 की power k. Here it was multiplied by 2 की power 0. Here it was 1 upon 2 square multiplied by 2. Here it was 1 upon 3 multiplied by 2 cube, so on and so. So basically I can write S2 की power k is greater than 1 plus 1 by 2. You can see it is k minus 1 and here the raised power is k 0. So overall it is k by infinity, or if k is made very large, then S2 की power k can also be made very large. And since S2 की power k, which is a subsequence of Sn, so therefore it implies that my series summation 1 upon n is bounded. Because for the series summation 1 upon n to be sequence of partial sum should remain bounded. And therefore, summation summation 1 upon n is a divergent series. Is a divergent series. Okay. Now, a few things that are very important that we should take. Summation a n converges. If summation a n converges, then limit a n must be equal to 0. Okay. Limit a must be equal to 0. Okay. See, understand, in order to generate a proof, just have an understanding that what is an. Summation an is convergent. It implies that sequence of partial sum associated with it is convergent. Okay. So we want or a Cauchy sequence. If Sn is Cauchy or convergent, then summation an must be convergent. Now, we know that summation an is convergent, then sequence also have an observation that this an is nothing but it is equals to Sn minus of Sn minus 1. And if I'm claiming that the limit an is 0, then I want to estimate modulus of an. Can it be made less than epsilon? This is what is my query. But having given what has been, the first thing that comes to mind is that Sn, which is the sequence of partial sum associated with the series, this should be Sn mod, can be made less than epsilon for all m greater than n, greater than some natural number. Okay, when it is true for all m, so can be made less than epsilon for all n greater than equals to n not belongs to natural. What does it imply? It implies for all n greater than equals to n not belongs to natural, which implies what? Which implies that an minus 0 comma n not belongs to natural, and would imply that limit an is equal to what? 0. Okay, limit n is non-zero. If limit an is non-zero, then certainly summation an is divergent. Limit an is 0, then it does not imply that summation n must be convergent. So converse is not. Limit 1 upon n is 0, but we know that summation 1 upon n is divergent. We have proven it just now. Okay, so please do take a note of this point. Another sequence, tail of the series. So one more observation that you can do or you can build here is that if, I'm writing it in black, if, then there would definitely exist some n belongs to natural such that the tail of the series, that is summation, can be made less than epsilon. It can be made less than epsilon. Okay. So how to go about it? It is easy. It is an easier observation when it comes. So if I'm saying that summation n is convergent, so I would say that let's edit it with this should be convergent, right? So Sn, which is equals to a1 plus a2 plus a3 dash 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 an, must be convergent. Okay. S, which implies what? Which implies that Sn minus S modulus can, greater than some number. Let's say n. Okay, so Sn minus S can be made less than epsilon. I can say that all the elements of Sn must lie between S minus epsilon to S plus epsilon. For all implies what? Implies that if I do this S minus Sn, it is greater than n. S minus Sn can be made less than epsilon. And what would be S minus Sn, by the way? A1 plus A2 plus A3 dash 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 An plus An plus 1 minus S capital N. Just think, what is this? This is S capital N. This gets slashed. So this can be made less than epsilon. Implies what? It implies that to infinity, An can be made less than epsilon. In other words, if I want to write the same thing, I can also summation, let us use some different number. M equals to N to K equals to, let's say I'm writing here, N, and K equals to N plus 1, AK. This limit would go towards 0. This is equals to writing what? An plus 1 plus An plus 2 dash 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 an, and this n is tending to infinity. So basically, this entire thing's limit would be equal to n d, and very important observation. Now, just a little bit of reasoning I'm going to ask from you. Now, if summation an is convergent, then summation an square is convergent. If summation an is convergent, does it imply summation an square is convergent? So let us see. Implies that limit an must be equal to what? 0. It implies what? An minus 0 equals to n0. Instead of epsilon, I have chosen epsilon to be equal to 1 because epsilon is any arbitrary positive real number. Then an minus 0 can also be less than 1 for all n greater than equal to n0, provided limit an is that an square would be less than an. Okay. And since an is given to be that, if I just take one thing, if I take just the sum k equals to 1 to n sk, this would be bounded. So it would be bounded. See, understand, an is convergent. Since an is convergent, the sequence of partial sum is bounded. It implies that corresponding to this, let's say, sequence partial sum is sigma k. This is also positive term series. So the sequence of partial sum associated with it would be an increasing sequence. That summation an square is convergent. Later on, we'll see a comparison test. Later on, we're also going to see a comparison test. Now, if you have this un less than vn, and if summation vn is a convergent series, straightforward, this is called as the comparison test. We're going to see it a little bit later on. So from here also you can converse it. Please do remember the converse is not. That is, if summation 1 upon n square is given to be summation, it does not imply that summation an is convergent. Why? Because see, just take an example. That summation 1 upon n square is convergent, but it does not imply that summation an is convergent. Then it implies summation an square is convergent. But summation an is convergent. Okay, this is one more. Now, just if summation an is convergent, then what can be said about e to the power of an? Is it convergent or divergent? Now you see, if I'm saying that summation an is convergent, then it necessarily implies that summation an is divergent. This is something that we have done. Now here, just think about this. Given that summation n is convergent, e power an would converge towards 1. So clearly, I can claim from this that summation e power an would be a divergent series. Now, one more assertion that I want to make, that if absolutely convergent, then it is convergent. If summation n is okay, let us see how. So if I'm saying that summation n is convergent, that implies the sequence of partial sum associated with the things. Let us say that the sequence of partial sum is Sn, and let us take the sequence of partial sum of summation an modulus is sigma n. If this is summation n is absolutely convergent, then we can say that sigma n minus sigma for all m greater than n greater than equals to n naught belongs to natural. Okay, this is minus Sm modulus. It is equals to what? It is equals to summation here. M is n, this would be n plus 1 dash dash dash, this would be n. So clearly, this would be equals to k equals to n plus 1 to m sk modulus, equals to writing an plus 1 plus an plus 2 plus an plus 3 dash m and sigma n are the sequence of partial sum of what? They are the sequence of partial sum of this absolute value. So basically, this is equals to this. So if I'm writing sigma m minus, it implies an plus 1 modulus plus an plus 2 modulus dash dash dash, because summation an is given to be absolutely convergent. It implies that is sigma n is Cauchy sequence. If it is a Cauchy sequence, it implies an plus 1 mod, an plus 2 mod dash 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 a mod can be made less than epsilon. Now, just so how can we show it? We'll have to show that the sequence of partial sum Sn associated with summation Sm would be simply an plus 1, an plus 2, an plus 3 dash 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 am, which certainly would be less than equal to an plus 1 modulus plus an, and all of these things. Since I know that this is convergent, that is summation an is absolutely convergent, all m greater than n greater than equals to n naught belongs to natural number. What does it imply? It implies that n, which is the sequence of partial sum of summation an, turns out to be convergent. Then summation an is convergent. then summation an is convergent. Okay, so without wasting time, I'm going to write it today, and from tomorrow onwards, we are going to do questions on this test, and this is an important test. Okay, so let an and bn positive term series or non-negative term series. It will include 0 also. Assume that an is convergent. It implies summation an is convergent. And if summation an is divergent, then it implies summation bn is divergent. Anything like an we don't know, and if we are not sure that we say that it is less than equal to bn, then convergence of bn would imply convergence of a. Why? Because of an would be convergent, that is summation an would be absolutely convergent. And if summation an is absolutely convergent, then summation an would be convergent. So this is called as all these things from tomorrow onwards. The class that we did yesterday and did we today contained. Pay much attention on these basic things, because this is what we are going to use in the coming lectures. Till then, take care. Bye-bye.